Welcome back. This is the last lesson in Chapter 1. We're going to be spending a couple days on this topic, solving ratio and rate problems. This is part 1 of 2 videos that you'll watch over the next 2 days. So, I want you to fill in your table of contents, page 31 and 32. The topic we're going to be talking about are proportions. Go ahead and fill that in and get your purple sheet that I gave you in class ready. The purple sheet you do need to just fold so that it opens up like a book. And I would like you to write on the top solving proportion problems, just so you know what it is when it's in your notebook. And we're actually going to first start with the blue foldable that we began in the beginning of the chapter. We have one column left to fill in. That's all about proportions. So we're actually going to go, I think it's page 23, back to this first. So we're going to deal with the definition of proportion first. A proportion, P-R-O-P-O-R-T-I-O-N. A proportion is an equation showing 2 ratios are equivalent. So last lesson we dealt with 2 ratios and how to tell if they were equivalent. Now we're going to be doing problems that asks us to solve for part of the equivalent ratio. So you can see one way, the primary way that we're going to be dealing with proportions are with equal fractions. You can use colons, and those are another way to show a proportion as well. I'm going to go down to the bottom and talk about what you should know before doing the center example. In a proportion, if ratios are equivalent, then, sorry, a little typo there, then the cross products are equal. So you are going to practice cross products a little bit more over these next couple of days, dealing with proportions. Here's a little hint. And I want you to star it. You'll always be given one whole rate, and then part or half of the equivalent rate, and be asked to find the missing piece. And I want you to think about all we worked hard with practicing on equivalent fractions with the lesson beforehand. We're going to need that skill as well. So the example in the middle, you have a little bit more on your page than I do. So I'm going to write in what you have and then go from there. A blank here and then 100. So there's not always going to be a setup like this done ahead of time for you. That's why I have a purple page to help us walk through when you have to create this. What's missing out of here is the words, the context, and that's the big thing that I always want you to start with. So let's read the question and figure out what these numbers actually mean. 10 students out of 25 have a dog. So let's circle students out of 25 have a dog. Based on these results, predict how many of the 100 total students in the 6th grade have a dog. So we're dealing with students that have a dog based on the entire group first, and then total 6th grade. So our words, the 10 is talking about dog owning students. Out of, say, a class of a total of 25, 10 of them have a dog. So the bottom number represents total students. The first ratio that we're given only has like maybe one class. Out of a class of 25, there's 10 of them that have a dog. But we don't want just one class, we want all 4 classes. And all together in the whole 6th grade, there's 100 students. So we have to figure out this missing piece. This numerator will be the answer to our question of predicting how many in the grade have a dog. So we can use equivalent fractions to help us solve this. 25 times 4 is 100. What you do to the bottom, you also have to do to the top. And when we multiply, we have 40. The answer is not just 40. You have to go back and put the context in. So 40 students own a dog. You could continue in the 6th grade. I'm just going to stop there. That's enough context for this one. Now grab that purple page. We're actually going to start on the right-hand side of the purple page. And just a little bit of review. We're going to talk about any problem where you're given one rate and then asked to find part of the second equivalent rate. That whole idea is proportion problem solving. So there are 3 ways that we can solve them. The example we did in the blue foldable used equivalent fractions. Another way you can solve these is more pictorial and visual using a bar diagram. There's some examples in our workbook, and I'm going to show that with the last one that I do. And also, we talked about this a little bit already. We're going to use cross products as another way to solve as well. On the left-hand side, I have what your notes have on the left-hand side, which are the steps for creating your own problem from scratch. There's nothing there to help you start it. So you're going to first read and mark up the problem. Then you're going to write words first with dealing with the units. You're going to fill in your known rate, what you're given, and then fill in part of the other one that you're given. And then find the missing part using those 3 strategies and write your answer with the units. I know I went a little bit fast. I'm going to do this example referring to this and do it step by step. So first things, we're going to read and mark up our problem. So Jim jogged 2 miles in 24 minutes. I don't care if you underline miles and minutes. I chose to box at that time. It's really okay as long as we're marking up our problem. At this rate, that's important. That means we want the same or equivalent rate. How long, that's important, will it take him to jog 6 miles? So how long, that's dealing with minutes. We don't know how long. That's what we're asked to find. So we've read and marked up our problem. Now we need to think, what are the units? What are we dealing with here? Our words are going to be miles over minutes. Now we're going to fill in the known rate. This first one that we are given is complete. We know the miles, we know the minutes. So the 2 is going to be in the numerator, the 24 is in the denominator. Now we need to fill in the known part of the other equivalent ratio. So remember, proportions are 2 fractions set equal to each other. We need to find one of these, but one of these units is given. We know he doesn't want to jog 2 miles. Now he's jogging 6 miles. So the numerator will get the 6, and the box, or the unknown, now is in the denominator. Before on your blue page, it was in the numerator. It can be any of those 2 spots. Now, we could also, again, try this with equivalent fractions because I'm seeing that 2 times 3 is 6. So I can do the same thing here, and I will get my new denominator, which is the minutes of 72 minutes, which is 24 times 3. If you didn't know that offhand, you can scratch it over here on the side. 12, 6, and 7. Okay? So my answer now is going to be with the unit. So 72 minutes is our answer. How long will it take him? To jog 6 miles, 72 minutes. Now, if I wanted to do this with cross products, I am going to show you that just to have you have that experience as well. So I'm going to write in red the equation again. I'm going to start with the same setup, but now I'm going to be using cross products. So I'm literally going to circle the 2 and the unknown, and that is going to be 2 times something is equal to, I'm just going to switch to black here, 24 times 6. So to solve this, I need to first multiply 24 and 6. If I wasn't sure, I could come over here. I got a 24 and a 12, so it ends up being 144 is equal to 2 times something. Now, 2 times something is 144. To solve this, we have to think of what is 144 divided by 2. And it ends up being that 72 as well. You can do it over here if you don't believe me. 144, 7, and you subtract, bring down the 4, and bingo. We got a 72. You can get it there both ways. If it's easier, if you see a fact that works, it's quicker to do equivalent fractions. But sometimes it doesn't work. You can't go maybe from 2 to 7 if this was a 7 and not a 6. Then you might want to use cross products. So that's why I'm showing you both ways. If equivalent fractions don't work with the numbers you're given, you can use cross products. The last example is one for you to try on your own, and then I'm going to come back and walk you through it just to make sure you understood it and did it correctly. A bakery cooks 15 cakes in 3 hours. At this rate, how many cakes can they bake in 8 hours? There's an additional little question at the end saying at what rate are they baking these cakes at. So go ahead and try this one. Pause and then resume when you're ready. So I have the steps here to help me remember for this one as well. I'm going to mark up as I read. A bakery cooks 15 cakes in 3 hours. At this rate means at this same rate. How many cakes can they bake in 8 hours? So let's think about that. We have to find the number of cakes. And then we're asked at what rate are they baking these cakes at? So at what rate means per hour. Let's set up our words first. We are dealing with cakes and hours. So we have our given rate of 15 cakes in 3 hours, and we are going to be asked at 8 hours, how many cakes would they bake? Now, there's a lot of different ways we can do this. Here's an instance where I'm looking at the 3 and the 8, and there's no way, equivalent fraction-wise, I can multiply that 3 and get an 8. So I have to do one of my other 2 options. If I were going to take this rate and draw it, 15 cakes in 3 hours, I would use what's called a bar diagram. So what happens is the whole bar represents the entire 15 cakes that are made. Okay? But we have to break it up into 3 hours because each one of these is 1 hour. At what rate are they baking the cakes? That's the unit rate question. They're wanting to know what is the unit rate if they're baking per hour. How many cakes would they be making? So because this is 15 divided by 3, they're making 5 cakes per hour. Now mathematically, I could also take that 15 and find the unit rate by dividing by 3/3. And I would get 5 cakes every hour that way. So you can draw the picture. You can also just find the unit rate. Now we can easily go back up here and find the answer for 8 hours. So what I'm going to do is right over here, I'm going to rewrite, instead of 15/3, that is the same as 5/1. And now we want to know how many cakes for 8 hours. Because it's a 1, now I can multiply by 8 and get 40 cakes. So my answer is 40 cakes in 8 hours. And the rate is 5 cakes every hour. Now, just for kicks, I'm going to show you the cross products because that would have been another option that you could have done. So you could, I'm just going to get rid of this for simplicity's sake. Answer is still 40. Here's another way we can prove it. We're going to take our 15 and our 8, and we're going to multiply them together. That's going to be equal to 3 times something. 15 times 8 ends up being 120. So we know that 4 times 3 is 12, so 3 times 40 is going to be 120. Either way, we get our answer of 40 cakes in 8 hours. The picture way, the bar diagram will always boil it down to a unit rate, and then you'll have to multiply by that hour of 8. So 5 times 8 is how we got 40 as well. We're going to practice this over the next 2 days, so hang in there. We are going to have part 2 to follow, so stay tuned.